Lab 3, question 1. So you see 5 different vectors labeled A through E in different colors. And we're going to label these vectors, or we're going to state what they are in 2 formats. So one format is to give the components of the vector in IJK notation, and the other format is to give it as magnitude and direction. And part of what you're learning this week is how to change from one format to the other and how to understand a vector in either format, and you have equations for that. So if you look at your equation sheet, you will find these 4 equations in the second column near the top, right after the kinematics equations of last week. And so these are the equations for finding components when you have the magnitude and the direction. So if we know the length of the vector and its direction, we can use these equations to find the components. If we have the components, we use this equation to find the magnitude of the vector, and this equation to find the direction. Keeping in mind that sometimes the angle you get, you have to add or subtract 180 degrees. So those are our equations. Now if we go to the problem, we can just, all of these vectors end right exactly on the intersection of 2 lines. So you just count the lines. 1, 2, 3, 4, 5, 6, 7. Wait, did I count right? 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 boxes this way. Takes me to where, as far along the x-axis it is, and then you'll count 8 boxes this way, which takes you to the end. So if you go 8 boxes along x, 8 boxes along y, you get 2 vectors, ax plus ay, that equal a. And it won't take you too long to figure out that they're all the same. Only, so what's the difference between A, B, and C? Actually, there's no difference, just where they're placed on the graph. And a vector doesn't change by where it's placed. You can drag a vector around as long as you don't change its length or its direction. It's the same vector. So A, B, and C are identical. And so we get the components from the graph. We use these equations to get the magnitude and the direction, but if your trig's good, you'll know that when the 2 components are equal, the angle is 45 degrees. So these are all going to have an angle of 45 degrees to the x-axis. When we go to D, the only difference is the x component's negative and the y component's positive. And so when you do this, you may, depending on your calculator, get the 135 degree angle that you want, or you may get a negative 45 degrees. There's where you have to add 180, because clearly D is not pointing in the negative direction. And when we get to E, you can see that both the x component and the y component are negative. And that gives us an angle from the x-axis of 180 plus 45. And so guess what? The length of the vector is going to be all the same. The angles of the first 3 vectors are the same, and the next 2 vectors are different angles, but they're all 45 degrees in one quadrant or the other. So that's problem 1. Okay, very much like the last problem, we have 2 vectors and they end at an intersection, so from the graph you can get the components. The difference is one of the vectors can be moved and you can place it, place it so that it's head to tail, right? That's how we add vectors graphically. And we can get the sum of those 2 vectors, and the sum, of course, as a single vector is a vector that starts where this vector starts and ends where the second vector ends. And so you can get that from the graph, and we can also get that by using our vector addition methods. And you can also actually, if you can see it, you can read the components of the answer right from the graph as well. So visualizing vectors is an important skill to develop. So find your way to this simulation and then pick a blue vector, put the base there, grab the tip, and looking at the numbers up above, you can get the magnitude of the vector and its direction. And so you just move it around till you get the 10.8 degrees that you want and the magnitude you want. And of course the magnitude you're dividing by 10 because you're not going to get up to 214. You need to get 21.4. And then you leave it there. I'm not going to do it. And then once you get that, then you get the next vector, and you put the base at the tip of the first vector, and then you do this. And also you see it's giving you the components as well. So it's calculating the components and the magnitude and the direction. It's doing it all automatically. And so you can do a vector addition problem using this simulation. So anyway, I did 4 random vectors, and I pulled in one of those yellow-orange arrows, and I show that as, right, if this is vector A, and I add to it vector B, remember graphic addition is head to tail, vectors C, D, then I start here, I end here. This single vector, let's call it R for resultant vector, is equal to A plus B plus C plus D, right? The result of this vector R is the same as A plus B plus C plus D. There is a question how, though, if we wanted to add a fourth vector E so that they all sum to 0, then we would have to take, then we would want to take this vector and turn it around. Put it there. Put it there, and then bring the head down here, and now you've got 5 vectors, A plus D plus C plus E, which equals 0. So it's important to distinguish between the E vector, the vector which makes the sum 0, and the R vector, or the resultant vector. That'll come up likely to come up in the quiz. Don't be fooled by it. Okay, last problem. Important to do this carefully. So here's my protractor, and you want to sketch it out a little bit so you don't go off the page. You want to fill the page but not go off the page. So let me just guess. I'm going to put this here, and then I have to mark. I've got to mark my origin, and then mark what? I need 40 degrees, so mark the 40 degree line. Then move my protractor away, bring my ruler in, and then I have to rotate it, right? So this ruler stretches and all that, but anyway. So let's see, put that there, line that up, and then draw the thing 10 units long along the edge. Okay. Then get the ruler out of there. And then I need my protractor. So that's vector 1. I get the length and the magnitude correct. I'll put an arrowhead on it. And then I got to bring my protractor back and put it right at the tip, right? The center of that protractor, right at the tip. And you got to make sure that the protractor still hasn't been tipped. And now, what's the next angle? The next angle I need is 135 degrees. I got to make sure this is exact. You got to be very careful with this. Line everything up uber careful. Make sure that protractor still straight, and then get 135 degrees. And whoops, I got to get my line mark. 135 degrees right there. Anyway, I'm not being very careful, but it's hard on the screen here. Then move the protractor away. Bring the ruler back. Whoops, the mark's going to move. Too bad. Then bring the ruler back. I got to turn it around. I'm stretching it. It's okay. And then I have to put this here. I got to line up with that. And you can see I'm going to go off the screen. I got to go 16 centimeters. And remember, you're reading between the lines. You're getting that thing so that you're reading between the millimeter lines. So you're getting 2 decimal places after the centimeter line, right? You're reading between the lines. And then you draw that line right along the ruler, 16 centimeters long. And that's why you want to sketch this out first, because you don't want to go off the page. Then move the ruler out of the way. You got to bring the protractor back up to the top. Where that ends, it's off the screen, but you know what to do. Let's just say it ended here. You'd put the protractor there. And now you got to measure 240 degrees. Oh, it only goes to 180. So what are you going to do? You're going to take the protractor and you're going to turn it upside down. Put it at the end. Make sure it's level, right? If you're twisted this way, you're going to have an error. You got to make sure it's square to the page and right exactly on the end. And then 240 is 180 plus 60. So in this case, you come down to where it says 60 and you'd mark it. And that will give you the line for your next one. Get the protractor out of the way. Bring the ruler back. I forget where the end point was, but you know, we're kind of fudging it right now. And put this wherever the tip of the arrow was. That's your line. That's your 240 degrees. And then what do you got? You got 140 grams, so that would be 14 centimeters. Of course, we haven't been doing this carefully, but you get the idea. Let's just say it ends there. And assuming we constructed this very carefully, we can now take our ruler and put this at the beginning and that at the end, and we'll measure the magnitude of the answer. That's the answer, right? It goes just as long as you line it up right. This is all assuming that you've done every angle carefully to 3 digits or 4 digits, and the distances all done carefully, and you didn't go off the page. And then you can measure this as your answer. Let me just write it in. So this would be my answer going from here to here. That's the length, though. I read it off the ruler. That is the magnitude. And then I get the direction. Remember, no calculators. I get the direction using the protractor. So get the ruler out of the way. Bring the protractor back. Turn it back to its right orientation. Put it back at the origin, make sure it's perfectly level. Of course, a real protractor, you can't stretch and compress it. And, you know, if I were reading this, there's 90 plus about 16 degrees, so about 106. And if I read between the lines, I might get 106.8 or something like that. I actually get 4 digits there. Always remember to read between the lines. So this is notice, just ruler, protractor, pencil, paper, no calculator. Do it carefully. Sketch it out. If you go off the page, adjust it so you stay on the page. And then take a photograph or scan it and send it to me. And hopefully, if you do it well, you should have less than a 1% error, so be careful. Oh yes, table of contents. Okay, I often forget to do this, but there are the times I started 1 at the beginning, and about 4:27 I did number 2, and then about 5:36 I started number 3, and at 8:32 I started number 4. Just in case you want to go just to a specific one, you can refer to the table of contents. You have to scan through the entire video.